It's not always sunny at the coast. However, one thing is certain, you will always feel, see, smell and taste the sea. Its significance in our existence transcends mere aesthetics. It is the lifeblood of our planet, a vital source of sustenance, inspiration and tranquility. From the rhythmic crash of waves against the shore, to the mysteries concealed beneath the surface, the ocean has woven its essence into the very fabric of our being. Yet, in our relentless pursuit of progress, we have betrayed this ancient alliance. The ocean, once a symbol of boundless abundance, now bears the scars of our neglect. We have exploited its riches with insatiable greed, plundering its depths for fish, minerals and oil, without regard for the consequences. The ocean's plight is a reflection of our own. We are strongly connected to its fate. The time has come for a moment of reflection on the price we pay for our negligence. It is not too late to mend our ways, to nurture the ocean that has nurtured us for millennia. The question that remains is whether we will heed to the call, rekindle our reverence for this watery realm, and work tireless to undo the harm we have inflicted. For in saving the ocean, we ultimately save ourselves.
The challenges that the ocean faces are also critical for our own health. The ocean provides us with seafood, but also with new medicines. It gives us new enzymes in technological processes, and at the same time, people in coastal environments are healthier and happier due to the proximity of the coast. Yet, we don't even know half of our ocean. We know more about Mars than we know about the deep sea. We think we know about 250,000 species in our ocean, but likely that's only 1/3 to half of the species that actually live in there. And when we think about the problems our ocean currently faces in providing us with food, with climate regulation, but also sea level rise and pollution, then we urgently need to improve our understanding of the ocean. And for that, we need to rethink how we do ocean science. And I cannot do this alone. We need to do this together, because the interactions between the ocean, between our health and environmental health, are so complex that requires interactions between humanities, engineering, and biological sciences, and so much more. We need to try to solve the puzzle together. We need to reshape how our scientific ecosystem is built. We need to break the boundaries between disciplines and remove the walls between labs and infrastructure. And that's what we will do here. Our Marine UGent Core Facility brings together infrastructure for a wide range of disciplines, so people can join their expertise, can tackle these problems interdisciplinary, transdisciplinary, and jointly. Let's go and have a look.
Welcome to the Marine UGent Core Facility. My name is Vicky Pauwelyn. I'm the Core Facility Manager. Our Marine UGent Core Facility brings together unique, innovative and multidisciplinary infrastructure with the aim to further facilitate and boost marine and maritime research in which Ghent University excels. The core facility at Ostend Science Park, with a total surface of more than 1,000 square meters, is specifically designed to address research needs that cannot be met on the current campuses in Ghent, due to the scale, the proximity to the sea, and its unique combination of engineering, biological and biotechnological research facilities in one infrastructure. Our core facility hosts a high-tech saltwater wave flume, a 20-meter-long construction filled with water, in which high-quality waves and currents are artificially generated. Our saltwater wave flume is unique in Europe, allowing to tackle key interdisciplinary research topics such as combining sustainable aquaculture with habitat restoration, metal corrosion on offshore structures, and nature-based solutions for coastal protection, like biogenic reefs, seagrass vegetation, and coastal dune functioning.
Hi, my name is Maximilian Streicher. I'm the director of the Coastal and Ocean Basin in the Flanders Maritime Laboratory, right behind me. I'm also assistant professor at Ghent University and the Coastal Engineering Research Group. And my field of expertise is the wave structure interactions in the coastal and offshore environment. There's a tendency towards nature-inclusive designs, replacing the current very traditional hard structures such as concrete or bricks for coastal protection structures. And this nature-inclusive designs can involve vegetation, space for a biota to grow, etc., to then result in wave attenuation over these structures. At the Coastal Engineering Research Group and at the COB, we're looking forward to use the saltwater wave flume for our research and to extend our research portfolio in that direction.
My name is Dries Bonte. I'm from the Faculty of Sciences, Department Biology. And in my research group, we are studying ecological and evolutionary processes that happen in space, not in outer space, but in a spatial context. And very specifically for this location, we are using the living labs to understand feedbacks between vegetation, so biological properties of the system, and the abiotic properties of the system, sand fluxes. Taken together, they form dunes, and that's why we are here. Understanding how the vegetation and sand dynamics are interacting allows us to understand how dunes are formed, and these dunes then are used as a nature-based solution. And nature-based solutions in which dunes are built and designed in front of the dikes, and they help us to protect the coasts for current sea level rise in the next 100, 200 years. So for the moment we are studying how these dunes should be designed in terms of their efficiency, not only to withstand storm surges in the future, but also how fast they can recover from potential damage after these kind of extreme events. So we are studying these processes here in nature. We are here in Ostend, close to the sea. But of course the aim is also to demonstrate the functioning of these nature-based solutions in an experimental way. So to have full control of the boundary conditions that are acting on both sand dynamics, wave impact and vegetation development. And that's why we are planning to use this kind of core facility, this saltwater flume tank that is planned to be built in our campus in Ostend.
This flume combines three crucial aspects. In contrast to the majority of the wave flumes, it is designed to use seawater instead of freshwater, allowing to work with living marine organisms. It contains a removable false bottom to facilitate installation of sediment beds, vegetation models and coastal structures. And the design also allows to simulate the production of marine aerosols.
We are using a set of tools to study wave structure interactions. At the Coastal Engineering Research Group in Ghent, we are using a wave flume, which is basically a long channel filled with water, where we on one side generate the waves, and on the other side we build in a model replica of the coastal structure, and then we are observing the wave structure interaction processes. Here at the COB, We're doing the same thing in a 3D environment in order to resolve the inherent nature, which is 3D of these processes. Both facilities are using fresh water instead of salt water. The extension of a saltwater flume in the core facility at Marine UGent will be a very relevant extension to this ecosystem of research infrastructures at UGent and at the Ostend Science Park campus Ostende.
My name is Maarten De Rijcke. I'm one of the research group leaders here at FLIS. For the last 7 years, I've been working together with Ghent University on topics related to microbial ecology. One of the research lines in which I've been collaborating with Ghent University is the occurrence of phycotoxins and bacterial endotoxins in sea spray aerosols. Our proximity to the ocean allows us to sample them in the field, while Ghent can perform the necessary assays to look at the human health effects. The benefit of the Marine UGent Core Facility is that it will allow us to use the saltwater flume to recreate wave action in a more realistic manner. In this way, we can create aerosols under controlled lab conditions, and we can include different larger scale structures such as sediments or macroalgae into our setup.
Besides the wave flume, we also offer a multi-species hatchery, which include facilities to culture micro and macroalgae, as well as larval and nursery units for bivalves and crustaceans. They are designed to host tanks with volumes of 100 up to 2,000 liters. All units are temperature and light controlled, and a central room with multiple recirculating aquaculture systems can be connected to each hatchery unit. This allows us to tackle different research aspects relevant to current aquaculture needs, including finding suitable starting material, sustainable water use, integrated disease management, and co-culture of several species of different trophic groups.
I'm Olivier Declercq. I'm the head of the research group Phycology. That's part of the biology department. And we research seaweed. So we specialize in seaweed growth, seaweed reproduction, and the genetics that underlie mainly the transition between growth and reproduction. So for us, the benefits of the core facilities in Ostend are definitely the ability to work in larger volumes. So here in Ghent, we have excellent facilities, but we're always limited to relatively smaller volumes for the cultivation of seaweeds. So we hope in Ostend to make use of much larger volumes that go to hundreds of liters of water. So the vicinity of the North Sea is very important in that respect. And what is also an added benefit is the saltwater wave flume, where we can do experiments with seaweeds in the proximity of engineers that can guide us in those experiments and analyze the results together.
My name is Annelies de Clerck, and I'm thrilled to share a glimpse into my world of aquaculture research. As the head of the Lab of Aquaculture and Artemia Reference Center at Ghent University in Belgium, I've dedicated my career to advancing our understanding of aquatic ecosystems and promoting the well-being of marine organisms. Now, you might wonder, why is the Marine UGent Core Facility at Campus Ostend so important to our research? Well, the proximity of aquaculture facilities to the sea is crucial. This is where the core facility comes into play. The unique setup allows us to explore and implement innovative approaches, such as utilizing wave flumes to address challenges like structural deployment, biofouling, and attachment success in aquaculture systems. Our connection with the Living Lab in the Oesterput here in the Speukom is pivotal. Starting materials can be cultivated in the aquaculture facilities at the Marine UGent Core Facility, and the Living Lab serves as a testing ground for these ideas. It's a seamless transition from controlled environments to the real-world scenarios. For instance, our expertise in disease monitoring, specifically for mollusk diseases in the Belgian part of the North Sea, aligns perfectly with the Living Lab's mission to bridge the gap between research and practical implementation.
Our core facility allows to harness the unexplored wealth of the ocean to pioneer marine biotechnology. We are not just studying the ocean, we are rewriting its potential in a sustainable way. Marine organisms are a source of various products, including biofuels, cosmetics, nutritional supplements, and enzymes used in industrial processes. Our facilities allow to further explore this potential, as we offer specialized infrastructure, such as a molecular lab, a cell culture lab, a mass spectrometry lab, as well as multifunctional dry labs.
Hi, my name is Silke and I'm a PhD student at the Blue Growth Research Lab. My research is focusing on sea spray as a potential contributor to human health benefits in coastal environments. The sea is a wide source of biodiversity. Multiple species live in the sea, for example, bacteria, microalgae, seaweed, fish, and large marine mammals. They all produce what we call bioactive molecules. These bioactive molecules can have a positive or a negative effect on other organisms. Think, for example, of fatty acids in fish oil or toxins in a jellyfish sting. These bioactive molecules can also go into the sea spray via a process that we call aerosolization. Once in the air, these bioactive molecules can become transported by the wind and inhaled by humans when, for example, walking at the beach. By using cellular and molecular assays, we'll try to investigate the effect these bioactive molecules can have on human health. The bioactive molecules that seem to have a beneficial effect on our health can be further investigated in, for example, pharmacological research. The molecules that we investigate in our lab can become the medicines of tomorrow. The core facility excels in bringing people together. For my PhD, for example, I will be working together with the Faculty of Medicine, the Faculty of Pharmaceutical Sciences, and the Flanders Marine Institute. In my research, I will take nose swab samples and blood samples to investigate the beneficial effects of the ocean on the long term.
To imitate the natural conditions as best as possible in our Marine UGent Core Facility, one thing is essential: direct access to seawater, which is provided in each experimental wet room. It is not artificial saltwater, but 45 cubic meters of authentic seawater stored in underground tanks. The state-of-the-art infrastructure of the Marine UGent Core Facility launches our researchers with a waving start into groundbreaking research.
Welcome at Ostend, where the sea meets innovation. My name is Eveline Diopere and I'm a research and innovation developer of the Marine UGent Core Facilities. These core facilities are located only 4.5 kilometers inland from here. Being near the coast has several advantages. Researchers can easily collect samples at sea. They can study marine life, they can observe ocean currents, they have direct access to seawater, thus they can perform experiments without the logistics of being far from the coast. Also, it supports researchers in the field. For example, it reduces the time between collecting the samples and processing the samples in the lab, which is sometimes crucial for marine research. For example, think of DNA analysis. We are located at Ostend Science Park, one of Ghent University's science parks promoting the sustainable development of the marine and maritime sector. It's a high-tech knowledge hub where researchers, companies and policymakers work intensively together. It's the first of its kind in Belgium and a perfect breeding ground to boost the blue economy. Our location on the Ostend campus is strategic because there are many complementary facilities in a radius of 5 kilometers, offering a strong Ghent University anchoring in the local ecosystem. First of all, there is a long-standing tradition in marine science, resulting in a broad range of knowledge and research institutions, such as the Flanders Maritime Laboratory next door, the Innovation Campus at the harbour, and several living labs, such as at the beach Deun voor Dijk or offshore like the Blue Accelerator. Also, we are surrounded by local, federal and European authorities, such as the POM, MUM, EMOT-net. And besides OSP, we have some key players in the blue economy. Think of the Port of Ostend, the European Food Centre. And being part of this local ecosystem, close to the sea, facilitates in-person meetings, joint expeditions and information exchange, fostering a strong, collaborative and dynamic research environment.
Traditionally, marine and maritime sciences has been fragmented. Biologists study marine life, while chemists look at the water composition and engineers design equipment and infrastructure. But the sea is a complex system where everything is interconnected. So to truly understand it, we need to break down these disciplinary boundaries. This is where the Marine UGent Consortium comes in, bringing together experts of over 70 research groups across 10 faculties at Ghent University. I'm Sara Vandamme and the coordinator of this consortium.
So the core facility will also allow us to collaborate even more with people that come from different disciplines. For example, we already have collaborations with the laboratory for aquaculture, where we explore the feasibility of co-cultivation of species for aquaculture of different trophic levels. So being able to access these facilities in Ostend will even stimulate that further. Another specific collaboration at the moment is with the group of Jana Asselman, who is very interested in nutraceuticals and the benefits that seaweed can bring in the development of a blue economy. So there we match our typical expertise in growth of seaweeds and genetics of seaweeds with her specific expertise on ocean health and nutraceutical discovery.
But we don't stop at research. Where traditionally we engage with industry and policymakers, in recent years we identified the need to involve citizens as well, turning knowledge into action. But how do we communicate with all these different stakeholders? This is a difficult question. For this reason, we reached out to the Faculty of Political and Social Sciences about 2 years ago, more specifically the Department of Communication Science.
My name is Eveline Cauberghe and I'm professor at the Faculty of Political and Social Sciences, where I've gained expertise within the field of strategic communication related to societal issues. Looking at today's wicked problems in society, we really need a multi-stakeholder perspective. And from that perspective, it's really necessary that we bring people together. And communication is crucial in this process to find common ground and to make people understand each other. Within our research group, we mainly focus on the general public. It is a stakeholder group that can no longer be neglected and should be considered. Within our research group, we mainly try to engage that general public within the sustainable transition.
Having state-of-the-art facilities where various disciplines join and collaborate is a game changer for advancing marine research and innovation. At the core facility, we're on a mission to establish ourselves as the central hub for multi- and transdisciplinary research and networking.
To bridge the gap between disciplines and to foster interdisciplinary research projects, we really need communication to bring people together. Communication is really the glue that brings people together and makes people also stick together, because we really want people across disciplines to work together. We really want them to break down the silos and share their knowledge, their know-how, expertise, and we even want them to go a step further. We want them to listen to each other and to really come to a mutual understanding. And communication can really facilitate this process by organizing workshops, brainstorms, conferences, but also network events and team buildings, because we also want to foster interpersonal relationships based on trust, because we want people really to work together, really look at the problem and be able to also reframe that problem and take into consideration the different angles that are related to it.
So if there's one thing that we've learned from Professor Cauberghe, is that adding social sciences to the equation to solve the wicked problems we are facing is really crucial, also to implement the new developments. Therefore, it is the aim of the Marine UGent Core Facility to develop high-standard, transdisciplinary research with both an economic and social
If you have a heart for the ocean, If you are looking for a way to exploit your marine activities sustainably, if you want to truly dive into ocean science and take the next step with your research, then here in Austin Science Park is where you need to be. Our Marine UGent Core Facility is looking forward to explore new solutions for the challenges of tomorrow together with you.